This is 7-2, Exponents and Exponential Functions, Problem 2 on page 426. The Got It. What is the simplified form of each expression in parts A through C? We're still combining bases with exponents, so as long as the bases are identical, we're going to add the exponents. But in these problems, we've added in a coefficient, okay? Not that big a deal. We just combine like terms, which in this case, the coefficients are considered like terms. So we're going to use our commutative and associative properties, depending on where, if there's parentheses or not. So we're going to combine our coefficients. So 5 times 3. Okay, this coefficient is a 1, which doesn't matter, so 5 times 3. And then all of these are x's, so we can add our 4 exponent, our 9 exponent, and when there isn't an exponent, we call it a 1. It's assumed to be a 1. So 5 times 3 for your coefficients is 15. 4 plus 9 plus 1 is 14, so we've got 15x to the 14th power. Part B, your coefficients are -4, 7, and 2. It doesn't matter that the 7 is in front of a D rather than a C. They're all coefficients, so they all go together. So it's -4 times 7 times 2. There are two C's, one with a 3 exponent, one with a -2 exponent. So we're going to combine those. And then there's the D squared by itself. Nothing to combine it with. So -4 times 7 times 2 gives us 56. C to the 3 plus -2 is C to the first, which again we don't write. We assume that that's a 1. And then the D squared. And that's as simplified as that can get. Part C, the only coefficient is the 12, so that comes out front. There's a j squared and a j, which is j to the first, so 2 plus 1. And then the k to the -2, there's nothing to combine it with because there's no other k. So simplified, that becomes 12 j to the third, k to the -2. As long as it is all multiplication, the order that you do them in doesn't matter, which is why we can combine our like variables.